Hello and welcome to Diagnosing Performance Problems. My name's John Snelson and I'm a Principal Engineer leading the Optic Engine team at MarkLogic. This is part 3 of a 5-part deep dive into the Optic Engine. And we're going to be looking at what to do and what to look for if you have a query that's running on the Optic Engine that is not performing as well as you'd want. To understand some of the things we're talking about today, it may be useful to go and look at parts 1 and 2 about the query plan operators and the way that we optimize query plans. And potentially you also might want to look up triple index talks number 4 and 5 to look at how the triple index is stored and to look at what kind of things can be efficiently queried from the triple index. So, as I mentioned, today the scenario is that you have a query and it's not performing as well as you'd want, and you need to look into why that is, potentially to be able to make some changes to that, potentially to be able to raise a support ticket with MarkLogic. So we're going to look at the various different trace flags that you can use to find out what's going on when your query is executing, and the kind of information to look for in the output that they provide. So the first trace flag, and maybe the most obvious trace flag we're going to use, is the Optic plan trace flag. That will output the query plan for the query into the logs. There are other ways to look at the query plan. One of them is to use the trace equals option to calls to SPARQL or XDMP SQL. There's a REST API parameter that you can also set that does tracing, and that will output the plans just for the query with that option set. So that could be useful if there's a lot of queries going on in the system, because the output can be overwhelming if all of the queries are outputting query plans at the same time. So there is also some functions. If you're using server-side xQuery or JavaScript, you can use SPARQL plan or XDMP SQL plan to go and fetch the plans for your queries. But I do recommend that you use the XML version of the query plan. There is a JSON version, but I believe that the XML version is a lot easier to read, and a lot of the tools that work on plans use the XML version, so do go and fetch that version. So you heard me talk about trace flags if you've watched previous talks maybe a few times now, but we should look at how to set those. If you go to the MarkLogic admin user interface, you can set a number of trace flags that you need to operate when MarkLogic is turned on. Usually these are done for debugging purposes, and often they're not left on, they're only turned on for specific purposes. So if you need to set a trace flag, if support asks you to set a trace flag, this is what you do. You go to the admin UI and you click on the group that your hosts are part of. Having gone to the group, you can then click on diagnostics on that left hand panel there. You need to remember to turn the Boolean trace events on to on rather than off. That's a step that I always forget, and then I wonder why my trace flags aren't having any effect. And then there's a text box where you can actually type the text of the trace flag in. And once that's submitted, that will be included in a list that will let you later disable that trace flag. And once you have a query plan, I do recommend that you try and visualize that in some way, because it's a lot easier to see what's going on in your query if you're visualizing that query plan. I've shown this link a few times now, but there is a visualizer that I have written as available on GitHub. So go to that link and check that project out there. You just paste your query plan into it and it will display it as an HTML page once you've set it up as a MarkLogic app server. So having got your query plan, there's a few things that you need to go and look for in that query plan to see what might be going on. And one of the things you might find in your query plan is you might find non-optimized, non-pushed down filters. And you'll be able to see that because of the plan::filter element in the XML. What that means is there's a filter expression that we haven't been able to push down, and that therefore we won't be able to optimize using the index access. That will just be run on every row one by one on the eNode. And sometimes that can be fine. If it's only running on a few rows, that's not necessarily going to be a problem. But if it's an important filter expression, where clause for your query, and it's a restrictive where clause, you'd like that to be able to be pushed down to the index. If you want to know more about what kinds of filters can be pushed down, then do go and look at part 2 of this deep dive, where under optimization we talk about exactly what kinds of filters can be pushed down. Another thing to look for is things like an inequality filter. So in this case, a not equals. We use the statistics of the database to understand what your data looks like, and to be able to estimate and cost the plans when we're optimizing them. But we don't actually have the ability right now to give good estimates for inequality filters like not equals, less than, greater than. So some of those may produce bad query plans or inefficient query plans simply because we don't have the statistics to understand what the impact of those filters is going to be. Have a look for sorts if you're using sorts. And look for the attribute here, the num sorted equals 0. That means we're going to have to bring all the rows into memory and do a brute force sort in memory, which is a lot less efficient, obviously, than having the query plan provide us with the correct sort order already based on using index sorting and things like that. Don't forget as well that sorts happen in other places, not just with an order by. They might be happening with a sort group algorithm. They might also be happening with the merge sort algorithms. They might also be happening with the merge sort join algorithms as well. So the next thing that I encouraged you to look for, and this using the visualizer is certainly makes this a lot easier, is to look for the pattern of scatter joins in your query. If you're writing a query and you're expecting that to return a relatively small amount of rows, then what you should see is a pattern of scatter joins that connects your most selective pieces of information from the query through to other parts of the query through joins that will retrieve more information. Now, if you look at the query plan that is being shown on the slide now, you'll notice that the topmost join is a parallel hash join, and on its right hand side there's a scatter join. So we're happy with the scatter join. That's passing the restrictive information from that filter that you can see on the left hand side of the scatter join through to the triple index lookup on the right hand side. But that top level template view is not restricted by a scatter join, and so we'll read the whole table there, and that might be an issue. What we'd really like to see is something a bit more like this query plan. Now there are two scatter joins in this query plan, and the lowest scatter join on that left hand side will be passing the restrictive information through into the template view, and then the result of that lowest scatter join contributes more contributes to the next scatter join, the higher up scatter join, and passes values to restrict the right hand side of that. So both template views are restricted by scatter join values that are passed in by the joins above them, and that means they'll be able to retrieve less information from the index and hopefully therefore execute faster. Now another thing to look out for is large joins. Again, really kind of talking about queries that are meant to produce a small result. If you see large joins, that could be a problem. Now, the way to look for that, or one way to look for that, is to look into the costing information that's embedded in recent versions of the plan in MarkLogic, or in recent versions of MarkLogic. Here, for instance, you can see we're looking at the mem cost. Now, I'm not suggesting actually that 165,000 is a high value there. But that is the attribute to look for, the cost estimate to look for. That is the peak memory usage for the whole of the subtree though. And so doesn't necessarily refer just to that join operator. Another thing to look for is that we build our hash table from the left hand side of the join operator all the time. So have a look at the estimated count for the left hand side of that join to see how many rows it's producing, and potentially also think about how many columns it's giving back as well, because the space used in that hash table is going to be roughly equivalent to rows times columns. So the next trace flag that you can use and that might give you an insight into what's going on is the Optic Statistics trace flag. And that will give you output like you see on the screen here. Recall I said that the statistics is really the optimizer's view of what your data looks like. So if there's not information in the statistics that would help the optimizer understand what your restrictive and selective attributes in the query are, or where clauses and things, then the optimizer is probably not going to do a good job of optimizing. So here in this statistics, for instance, we've got several counts. Now, if you look at the counts on these lines, that's probably the easiest and most obvious thing to look for. That's 150,000, and so is this one. This one's a little better, 82,000. But really the most restrictive, the lowest count at statistics here are still 56,000. And so that's not providing us with any information or any conditions that let us reduce, understand that the query is reduced down and selective. Now, in this case, I think the query isn't selective, and that may be why you don't see this. But then if you're returning a lot of rows, you'll get the performance related to returning that number of rows. In the statistics, what I usually hope to see is something like this. Here we've got a count of 46. So that's an extremely restrictive value. This value is actually the PFLT string that you can see from the query in the bottom right there. So we're saying stock symbol equals PFLT. And here's the statistics for stock symbol. And we can see that the count is relatively big. But on the unique objects, remember that the value of that column lives in the object. There's 758 unique objects. So we're only selecting 46 of that 758. So that's actually reducing the number of rows that we select quite a lot. Another trace flag to look at is optic execution. And that shows you the contents of the plan and reducer that gets sent to the D node and executed on the D node. So that will include index lookups, but it may also include other operations too. One of the things that will get sent to the D node is the list of scatter values that we talked about. And so one thing to look at potentially is how many values are being sent to the D node. In this case, I've artificially increased the number to 100,000. That may be a big issue to send that many values to the D node and then to look up that many values in the index once we're there. Other things that could get large get sent to the D node, like in a broadcast join, you might send a whole hash table to the D node. So you'll also see counts of rows in things like that. Something else to look at is what reducer is being used on those dnode calls. In this case, it's unordered results, which is the fastest reducer. Other reducers are slower, and so if you see those, there may be things you could do about that. Of course, you might see a grouping reducer that does aggregate calculations and grouping as it's reducing. Although that is slower, that's usually faster than doing grouping on the eNode. So if you've got a group operation in your query, you would actually like to see that as a reducer step. That would be a good thing because it will be executed in parallel across all the dnodes at once. And further, if you've got this far, maybe you are not quite sure what action to take on the information you've received, or you're still drawing a blank, you may need to raise a support ticket with MarkLogic support. When you do that, please be sure to include the output from the big 4 trace flags that we've just talked about: Optic Statistics, Optic Optimization, Optic Plan, and Optic Execution. If you don't include the information from those trace flags, we're just going to have to come back to you and ask you for the information. And that's going to put a whole delay on being able to deal with your support requests. So that is kind of important. And remember as well that you can use the trace option to report on that information just for a particular query rather than for all the queries that you're running in your application. So to recap what we've just looked at, number 1, get the query plan. Do get the query plan, become familiar with them and understand what might be going on there. Visualize it potentially with that visualizer project. And things to look for are filters that aren't pushed down, inequality filters or other filters that we haven't got good statistics for, brute force sorts, the pattern of scatter joins and whether that's passing the restrictive information around the plan well, and large hash joins as well potentially. Do look at the statistics, look for selective values, look at the view that the optimizer has of your data, and look at the execution calls for problems, potentially large scatter constraints, a sort that isn't pushed down, grouping that isn't pushed down, things like that. And raise a support ticket if you need help, but include the output from those big 4 trace events. Thank you for listening.